Okay, cool. So, good afternoon. Welcome to Dreamforce. Welcome to the session, Clean Apex Code with Automated Code Metrics. I'm Robert. I work at Up2Go. I'm a lead product developer, and my wonderful co-speaker will just introduce himself.
Hi, everyone. My name is Lorenzo Frattini. I'm a certified technical architect and creator of Clayton.io. We're very, very excited to be here today. We didn't expect such a full room.
So many people.
Boring topics. No, actually, we're very excited about what we're talking about. We've got a lot we would like to show you. So let's get started.
Cool. So just a little bit of context. You see, we don't have the same accent. We are not from the same company. To be honest, we just met recently. What brought the two of us together here on stage was that we had the same problem in the last year and solved it by building a tool. And the problem we had was like enforcing code quality in our work context. So this presentation will be about two stories. I work for an ISV, so it's about products. Lorenzo is doing consulting and projects. So different mindsets, but tools. Yeah, there will be a lot of demos. There will be hopefully a Q&A, so don't leave the room. We have to show that one. Everything you are going to see is not a Salesforce product, so don't make any purchasing decisions based on it. Actually, I have that one. Okay, let's start with defining the topic. It's about what is good code. And when we worked on the slide set, we basically went through other Dreamforce sessions about coding and blogs. And there are different ways to define what good code is. There are people who say, okay, think of the customer. Code is just a means to an end. We get paid for working code, so make your customer successful. Other people, they think about technology. We need to have tests. We need to have coverage. We need to use the latest stuff that's out there in the release notes, governor limits. And yeah, there are other people, they say it's about planning. You have to be agile, plan in sprints. So while we think this is perfectly right, we think this is not good enough. If we want to talk about really the inner stuff of code. So this is a tech talk. This is a tech conference. Let's show some code, ugly code. Don't try to understand it. It's from our internal expense tracker. So it really fulfills all the criteria I just showed. It works. It makes us really successful reimbursing expenses. It was planned using Scrum. But just imagine you would have inherited this code from a fellow developer who just left for a better job. Would you like it? So is this good code? I actually planned on asking the audience, just raise your voice, but no. So do you see anything that you don't like? Just did I hear socle in loops? Okay. I heard some good stuff. Do you want to add anything before I show what I found?
No.
Okay. So this is what I found when I stumbled over the code. I don't like comments. Actually, it should say outdated comments on the top. There are many book authors. They say comments are an excuse for code that is hard to understand. So actually, the code should speak for itself. We do managed packages, so we hate global. There are many developers, they think batch still needs global. Long parameter lists, I hate it because my IDE doesn't tell me which date comes first, and 3 in a row, it's really ugly. I heard socle in loops. It works for us, but I think if we get more employees after this talk, it might change. Yeah, and there's something I really care about, and this is deeply nested logic of if, else, and for. It really makes it hard to test because for each way through the code, you need an extra test, and yeah, formatting, white space. So you all said no, so I think we agree all that, that this is not good enough. So Before I'm going to tell you what we at Up2Go did, I just want to compile a short list of high-level qualities of code. On the slides, there are some quotes. I won't read them. It's just to support the argument. We just picked up some quotes by some experts. So, good code is easy to maintain. Code is not written once and then left unchanged for the next year. It's really about going in, changing stuff. So don't think about quick hacks, pragmatic stuff. Think about a long-term partnership. Even if you don't have to take care of the developer who's working with your code, he will love it.
And good code is easy to understand, and by that, what we mean is that it's not just code that compiles. It should be easy to understand by humans, people that will read what the variables name are. They should understand. Everything should be named in a way that suggests their purpose. The flow of the code should be nice and easy to follow, not too much convolution in the code. Otherwise, that will become very, very easy to make mistakes and to introduce bugs. Names, we will talk about that later, but we always suggest to have names that really tell you what that specific class or variable purpose is. For example, if you use design patterns that are well established, suggest that with the name. Suggest that the factory is a factory, for example.
Right, don't use nerdy names, use the names of the domain. Right, so code that easy to understand is not always easy to extend. So this is really important. Just think of classes of 1,000 lines, a big spaghetti mess. Adding features is really hard. So think about design, encapsulation, good object orientation. This is really important. Otherwise, you see yourself rewriting old features when you want to add new one. You might have heard of technical debt. You really accumulate stuff with everything you add. So when you don't refactor and keep the classes small, this will really be a problem. So keep yourself agile and think about how your code is easy to extend.
And good code is easy to test. So not sure if many of you use test-driven development. That is a way to make sure that you write your code with tests in mind. We believe that is a good way of doing it, but even if you don't do it, you should still write your code with the idea of it to be tested in a nice and easy way so that the tests are simple to understand, like the code itself. Good tests are thorough, are repeatable, are independent of the data, and they should be easy to follow. They should be as good as your code. So good code is written with testing in mind.
Right. And this wonderful person, Ken Beck, I think he's the inventor of JUnit, he says, every test must fit on the screen. So if you see yourself writing unit tests where you set up the whole application, it's wrong. It's not something wrong with Apex or anything else. It's something wrong with your code. So I just want to sum it up. Good code is clean code, and we didn't came up with this word. It's from a wonderful book. You see, I like books. This is like the Bible at Up2Go. Every developer has to read it once a week. And this book is really about everything, about naming, about intention-revealing stuff, about beauty in code. It's really about soft facts. So go out and pick a version of this book. It's really good. So I told you we want to talk about how we do it. I work at a ISV company. We have managed packages out there. One package is a financial planning solution for automotive. The other one is collaboration and matrix organizations. So heavy enterprise stuff, native packages. And we have teams spread around the world. We have offices in the US, in Germany, in Austria. We just opened an office in Paris. And all the teams, they have people from the university, people like I'm quite older, so different skill levels. And how do we tackle that? As always, I think it's kind of trivial. I guess everybody does it, but you have to educate your people. And it's not only about the latest stuff In the Apex world, you have to go back. Apex is not really very different from Java. So read about object orientation, read about legacy code, testing. You need to train your people and tell them quality is their own responsibility. Lorenzo talked about standards. It starts easy with naming, but also implementation patterns. How do we do batch in our company? Best practices, which libraries we use. And reinforcements, Apex Commons basically in all our products. So when we switch people from teams, everybody understands how triggers work. And this really helps. We do pair programming. Code reviews are mandatory for every non-trivial change to the system. And this is all good. I guess many of you say, yeah, this is not new to me. And there was a problem we found out when there was a stressy time, we just let loose. We didn't do it. And as we are developers, we said, why not have tools check some aspects of quality for us? I'm quite sure that even Einstein is not feasible. It's not possible to find out if a name is intention revealing, but there's a lot of stuff that can be done. And we come from a Java background, and there are zillions of tools, static code analyzers, formatting tools. And we just made a small project and ported one of those tools. There is a Java project. It's more than 10 years old. It's called PMD. It's a static code analyzer. It basically reads in your classes, has a list of rules. Each rule is a Java class which finds anti-patterns, problems in code, and outputs violations. I will show in a minute how this looks like in Eclipse. There are plugins for many other IDEs out there, but it's still local. And we thought, having stuff locally, it's still the responsibility of a single developer. So we want to have it in our, really tightly integrated into the development process. And so we said we want to have it in GitHub. We found a company in New York called CodeClimate. They have a cloud service which plugs into your GitHub repo, and every time you do a push or a pull request, it runs engines on it. And what we did, we basically wrapped PMD as a CodeClimate engine. And so, yeah, I'm going to show you how this works in GitHub. Yeah, and the best thing is we just got started, and everything is open source. So I hope to get you guys excited to contribute some of your Salesforce knowledge. So let's switch to the demo. In our abstract, we promised to help you see how easy it is to use for you. So the demo will be twofold. The first part, I will show Eclipse because I like it. I'm quite old, so I like Eclipse, but there are PMD plugins for other IDEs. And then I will switch to GitHub and show you how PMD and Apex metrics work together in GitHub. Okay. Good. So this is Eclipse. It's my travel expense project. You see the problematic class we saw before. To get PMD into Eclipse, it's just pasting in the update site URL, and then it's in there. And what I just do, and you can do it after the session, so just get this URL and put it into your Eclipse. I just click on source, ask PMD to check the code. And after a few seconds, you see there are markers on the lines and on some classes. I will zoom into the violations view. And you will recognize some of the problems we talked about before. It's telling me to avoid global modifier. It says there's an excessive parameter list. Down there should be avoid SOCL in loops. And something which sounds quite scientific, standard cyclomatic complexity. It's basically counting the different ways through the program. So it's about testability. If you have a high cyclomatic complexity, it's hard to test. Good. So PMD works on the command line in your IDE. You can integrate it with Ant, your own CI process. But let's look how this works in GitHub. So I just switch to my GitHub repo. It's a private one. CodeClimate is for free. So when you do an open source project, you just get CodeClimate for free. And you can use Apex metrics instantly. So the cool thing about CodeClimate is they basically extend the GitHub UI, so you don't have to leave GitHub all the time. You see on the top, there is this green grade, a GPA. So this repo gets a 3.3, which is quite good, so it's green. And this is calculated from the grade of each class. Let me just drill into my classes folder, A, wonderful. And down there, the class, the problematic one, got a D. Why that? And here, inside of GitHub, so this is not CodeClimate, you see all the issue markers. Global modifier, long parameter list, problematic naming, avoid SOCL in loops. And each of those violations goes back to one of the PMD rules. So when you click on the expand button here, you see the PMD version, an explanation of the rule, and something called PMD properties. You don't have to live with the defaults we came up with. So if you say it's totally okay for us to have 4 parameters in a method, I just don't like 6, you can override it. And you do it by simply placing an XML configuration file in the source folder, where you basically would override this value, and then the Apex metrics engine would just interpret the rule differently. So CodeClimate also has a very nice UI. So I just switched to the UI of my travel expense app. I compare it to a chatter feed. Whenever somebody's doing a commit or a pull request, you see code has changed, it's gotten worse or better. There's this circle which explains how the overall grade is calculated. There is a list of hotspots, so we really have to take care about the travel builder class. It's really a lot of problems in there. Right. So if you want to find out more about this, just go to CodeClimate. There is a link to the Apex metrics engine, and you will be directed to the open source project of that. We have a quite decent wiki, so if you want to contribute rules or if you just want to change something, you can do it. It's an open source project. So, I overran the time terribly. So I will just switch to Lorenzo, who will talk about Clayton and code reviews.
Thanks, Rob. So just get this one. Okay, so thanks, Rob. We come from different kind of contexts. Rob is from a product organization, so they work a lot they keep going back on their code. I work in consultancies, and we have different challenges. It's more about getting things right straight away. It's kind of difficult to go back and refactor, right, when you charge by the hour. Why is code quality so tricky? So if we kind of take a step back and try to look at the bigger picture, having good quality requires kind of a mature organization. If you think about what is required to get to that point, you probably require standards to be developed. As an organization, you need to make sure that everyone understands those standards, and then you have to enforce them throughout, and that is very, very tricky. It's very difficult. Code quality is hard to measure. It's not the same for everyone. And if you have multiple projects in parallel, like the scenarios I deal with every day in my, at work, it's kind of difficult to do it at scale because you need to make sure that every project is doing that. And then in the Salesforce space, there is also this unprecedented velocity. A lot of things are taken care by the platform. So it's quite common to see this very, very fast development cycle. And sometimes there is an injection of offshore resources or temporary developers, contractors. They don't really care about the quality of their code. Well, let's say they might care, but they're normally not held accountable for that. All these things are real challenges. And in my career, I've been working with this problem, trying to solve it a number of times. And the approach I think that worked best for me is the code review approach. Code reviews, I don't know how many of you do code reviews. The idea is extremely simple. You start building your own set of coding standards, so whatever as a group, as a team, as an organization is good quality for you, that should be part of your coding standards. So that could cover anti-patterns, like bad things that you should never have in your code, like succulent loops, like we said earlier. But it could be also about the style of your code, about the way you name things, about how convoluted your code can be. And the idea is that you define these coding standards, and there is a lot of help out there, a lot of literature. And then you come up with a code review checklist. The idea of a checklist is very simple, is testable things, 10 lines, 10 points, so that there is a moment in the development, and normally there is when there is a pull request in the repo, where two developers, two peers, sit together, go through the checklist, and make sure that your code complies, so it's good enough to be accepted in the repo. And that is very good because you kind of don't fix the big picture. You don't fix everything. You don't erase your technical debt. But by fixing increments, you make sure that every time you do something better. So even if you started with a terrible code base, every addition is better. There are challenges, though. This is not easy to get right straight away. You need, if you've got a large organization, you need to train a lot of people. And then there are deadlines. And when there are deadlines, if you've got a deployment in 2 days, chances are things will slip through because people are stressed and they want to get the code in. So it's hard to discipline ourselves. And that challenge, and that is what I was most worried about, was the scalability of this approach. Working with consultancy organizations, our challenge is we're running many projects in parallel, and we needed a way to simply solve the problem throughout our portfolio. So I've been doing this for a number of years, quite successfully, but I kept thinking, can I automate this? Can I have some sort of automation, kind of commenting the pull request, like a human developer would do? And I kept thinking about this because I was intrigued by the idea of an automation that will never make mistakes. Well, unless it's buggy, but you get the point. So I came up with what I later called Clayton. I wanted it to sound like a person. So I just named it like it was a 5-minute thing. So I started Clayton as a prototype early this year. And the idea was I wanted something very simple. Just a comment is good enough for me. I just want to make sure that bad code doesn't slip into the repo. And I want it to be hosted. So there are a number of solutions out there regarding static code analysis. The point is that you, most of the time, need to install something like SonarQube, for example, is something you need to manage, either install on AWS, then manage. I wanted something that is managed, basically, and specific to Salesforce development. And the idea is that you go in, I will show you a demo, you go in, you define your coding standards, and the tool will enforce these coding standards every time there is a new change. So I will show you how it works. It connects into GitHub or Bitbucket, and every pull request is basically kicking off a new check. So in terms of the story of Clayton, I was working on this idea, and then I met Mark Richards, which is the CEO of a very cool company. It's called makepositive. It's an implementation partner. They've been awarded yesterday at this Dreamforce, and they're a pretty cool bunch of guys based in the UK, in India, very, very well respected, a lot of track of good projects. The size of the team is approximately, I think it's 50 people more or less. It's 25 developers, a mix of onshore, offshore, and I think at least 25 like admins. And they were, in terms of maturity, they were getting there. They developed their own standards. There was a feeling of good code. The challenge was we're running multiple projects at the same time, at least 10. And how do we enforce the standards? It's not easy. If we can put our good guy on a project, okay, we are kind of okay with it. We will have code reviews and it will work, but how can we ensure it for everything? So I started working with Mark, and I said, listen, I'm working on this idea. Can we try together? And that is when Clayton kind of started out. So I'd like to give you a demo of how it works. Okay, so just to give you an example, I've got a project on Bitbucket. This is nothing really, it's just a little bit of Apex. I don't know if you're familiar with, I assume that you all are very familiar with version control and Git. Basically, Bitbucket is a way to do it. And the way Clayton works is basically is online, is hosted on a Roku. The idea is that you connect it with your repo, and you have to trust it to access your code. And it will basically give you a list of the things you can see. Now, the code that I showed you is like, there is no checks, it's just Apex code on a repo. And if I want to start adding code analysis on this, all I have to do is to click once, and Clayton is checking the code and running a lot of good checks. I will show you in a minute how it works. But basically, analyze the code and kind of, it gives you an overview of what's going wrong. But we will go back on this now. Let's assume I'm a developer. I'm a developer working on this code base, and I've got a new feature. Now, the development life cycle, I always suggest to create a feature branch where you start working on your new exciting feature, and then I'll do something very bad. I will do it directly from the browser, and don't do it. So I go in here and just paste a new file. I think I have it here. So let's assume that this is a very, very cool feature. Let me copy it from here. It's one file, but it could be many. It could be 10 files, 10 classes. And OK, so I'm adding my new feature on German keyboards. OK. So this is just an example. This is a commit. I might have to do many. I will write my test. And when the feature is kind of stable enough, I will do a pull request. And the pull request is the moment where we should start having the review. No, I want to do a pull request from demo to master. Yeah, let's do this. Now, what's happening now is that this is basically the moment where normally another person should review my code. What happens is that Clayton has run the check automatically. And as you can see, we've got a status. The code review has failed. That means that the code is not good enough to be merged into our code base. And there are comments on the offending line with the problems that were spotted. So not with sharing. You should use with sharing. There is a hard-coded ID. You should never hard-code any ID in your code, and a bunch of other things. There was a DML statement inside the loop, so very bad things. So now, as a developer, I can go back and change it. The way Clayton works is actually, I talk about coding standards that every team should develop. So the idea is that there is actually a way to go in and say, I actually want to enforce all these things. For example, I might not care about the naming convention, but you might want to say, I want all the classes to be named in a certain way. So for example, I want to use this pattern because I use a namespace. And you've got the flexibility to say, I want tests to be called this way. I want only single letter variables in loops, and everything else should be prevented. Things like that. Okay, there are a number of rules, avoid empty method, a number of things. So that's a demo. Let's go back. We would like to leave some time for some Q&A, so I'll go through the results. So just to tell you that there are actually good results. We've seen the quality of delivery in general going up. We measure what is the defect density, is basically how many lines of code have problems. And that is the history of a project of 18,000 lines of Apex. And the defect density goes from 21% to 3% in one sprint, 10 days. And that is real data. We know that the team is now more knowledgeable because they talk about code reviews now. They care about it. It's a topic they discuss. And we think that code review become more effective because if you have a tool that takes care of the dull work, you start talking about more meaningful things, how the code is architected, what the patterns that we're using are the right ones. And then you want to say this?
Yeah. People trust tools more than people. In my experience, when we did code reviews before, it was a lot of discussion. Hey, this is just an opinion. And when we basically just put the opinion into a tool, there was less discussion. And I don't like the result, but that's the truth, at least in my reality. And another thing that is really cool, it's somewhat gamifying coding. In the beginning, everybody hated the idea that I put a grade on a class or code. They said, no, will you tie my salary to it? No. But now we see people really, they go out and refactor code to just get an A, and it's really, it brings the fun back into coding. So yeah, this is cool.
A few takeaways. First of all, we think it's not just about developers, it's about the culture. Code quality and technical depth affect everyone at every level in the organization. So create a culture where code quality matters, where there is people talk about it. Make sure you train and educate people on code quality aspect. That is really important. Use code reviews. Very, very simple, but extremely powerful. And let tools help you. We feel we just started. I mean, I think we started working on these things early this year, and we already have data to support like the powerful effect that using tools have.
Just try them out all.
Try them out.
It's really, every tool is perfect for a specific situation, and we really would love to see some of you contribute knowledge. So just get into the space. Tooling, creating tools for Salesforce is really cool. It's fun. I didn't say that. I actually planned on doing this. I couldn't have done this without support from Salesforce. So when we tried to understand Apex, we just got a parser from Salesforce. So yeah, maybe you just want to join.
Yeah, absolutely. So the important thing for us is that we want your feedback. We've been doing a lot of things, and we worked hard to get to this point. And now we're kind of proud to show this for the first time to the public. So please get in touch with us. Try our tools. Everything we show, you can go straight away and play with. You can go on Clayton.io and connect your project. You can go on GitHub and contribute to PMD. And we will share all the links in the chatter feed straight after the session.
And we will hang around here. So
yeah, we're happy to demo and everything. We're kind of very, very proud of our babies. And please join us in this journey for better tooling.
So, thanks.
Thank you, everyone.
Let's open the Q&A. Very good. There's a mic, so if you don't want to be the person who runs there, I just shout it out and I...
So one question.
Yeah.
Before you deployed PMD or Clayton.io, and after you deployed it, did you see a general increase in cycle time in code deployments, or decrease in cycle time, or gradual decrease in cycle time in code deployments, or?
Yeah.
You mean, yeah?
So in terms of using Clayton, there is absolutely no overhead, because code reviews are happening already. Normally, a human takes 1 hour to review roughly 90 lines of code. That is kind of suggested. And you have to wait for that person to be available to look at your code. So the pull request will say open more. Using the tool, we see that kind of, it's shortened. The feedback, as you've seen, is instantaneous. So from what I can tell, absolutely not. It's actually bringing up, it's actually a faster development life cycle, because a lot of things are taken care of straight away. You want to add?
Yeah, we have fixed sprints. I just saw the quality going up. So when we do a code review, there's already some of the trivial stuff not in there, so we don't have to talk about it. So it definitely improved from the very first sprint that we used it.
Okay, thanks.
So anybody else? Yeah.
Hey, I have another question.
Oh yeah.
Is it able to validate the governor limits? Let's say multiple developers went to org and developed the code, multiple triggers, multiple classes.
Yeah.
We get into a loop where runtime you get into the sock call limits or some kind of an errors.
Yeah.
Can we predetermine those things to save some time at the deployment time?
Yeah, so that is a very tricky thing. So we cannot tell you if your code will break governor limits. That depends at runtime. But we can tell you if there is a high chance that will happen. So, for example,
Sockle in loops.
Sockle in loops is something we get. Send emails in loops. It depends on the different tools, but we are definitely working to resolve that problem. Right. Now, there are things that you cannot really be absolutely certain, but you know that they are bad practice, and that's what we block.
Right.
So I have another thing, how different is this, right? If somebody writes a test classes, link that to the Sonar Cube where you can see the matrices. So
no.
How different is the Clayton.io from that standard stuff?
So none of these tools work with Sonar Cube. They are different type of solution.
Yeah, so you cannot plug it in. So I think Sonar Cube works with PMD. So as what we contributed is really part of the base PMD package, it should work with Sonar Cube. So yeah, and it works with Eclipse and so it's not a special branch of PMD, it's really part of the main repository.
Product.
Yeah.
Okay, thank you.
Hi, question.
Hi.
Okay. So I've heard of some other tool called Checkmarks.
Yeah.
And I was wondering if you could tell me how this compares with something like what Checkmarks does.
Yeah.
Oh, Checkmarks is a different, it plays in the same arena, but Checkmarks is more about if there are any field level security problems, sharing. I know Checkmarks from security reviews, and I think there's not really an overlap. So we are not competing with them, but I think you could combine both. Even if they don't mandate it in the security review, it's perfect if you just put
so
clean code.
So you could combine both then?
Yes, absolutely.
Definitely.
Okay.
So in terms of the overlap, Checkmarks is an enterprise product with a long history. Our tools are babies. And there is something that Checkmark does that our tool doesn't, is compiling is basically able to tell you if things are indirectly wrong. So there is an extra layer of depth in the checks, but it's also an enterprise product, so it has a different impact and cost and everything. So we have a vision to maybe fill a little bit of, reduce the gap, and hopefully over time, with everyone's help and contribution, we will fill that gap. But at this point in time, these are simpler tools. They suggest you what should be improved, and they work, but they don't go that deep.
All right, thank you.
Hi.
Hi.
In Salesforce, there are a lot of other things that can be checked besides APEX, such as validation rules and formula fields and naming conventions of custom fields. Do you think that could be automated as well, or
not yet? So
it's definitely possible, and I simply think we haven't thought about it. Kind of solving the problem with the code is the hard part, because parsing the code is the difficult part of it. So there is definitely a possibility to add in the future checks on naming. It's actually a very good idea. Thanks for that.
No problem.
And I don't know if Salesforce already talked about it. There's a lot going on in the tooling space. So at this Dreamforce, you will hear a lot about Salesforce DX. And I think tools like this will merge with other tools. And so I think there's
Exciting stuff.
And in,
safe harbor.
and Clayton, is it possible to implement your own rules as well?
No, not at this point in time. You've got a degree of configurability, but it's not possible at this point in time.
Okay, perfect.
Thanks.
Do you guys have any future on looking at that codes? We have codes that are written by consultants, and new consultant companies switch over, don't use the that codes anymore. So trying to look for a tool that can help us analyze that.
I'm not sure I understand the question.
Yeah.
Is that possible to help this process? Definitely, it is possible.
Just put it into GitHub or
and run the tools.
And run the
and you will
tools
get a
over.
report, and you give it to your consultant, and you say, fix it.
Yeah. And if you don't use GitHub or don't like to put your code on a cloud platform, just do it locally with PMD. So you can open all the projects in Eclipse and do an analysis over it. That should work. No. For understanding test coverage, you really need to, I think, know more about the classes. You need to run them. I don't know.
So test coverage is something that we can only ask Salesforce to tell us, because it's processed server-side. To keep it very simple, what we do is basically, we don't even connect to Salesforce. What we do is
we read classes and
parse
code
them, give you feedback locally. Well, locally or on the cloud, but without that connection that will tell you this is the coverage.
With just one question. Last question.
So, isn't the roadmap to implement this in another platform like Visual Studio or like?
So, I think you can already use.
PMD has a plugin for basically most of the IDEs. I just heard that IntelliJ will at some point.
I'm going to put it in.
Yeah. So I think so. I'm not sure, but it's not at my roadmap. You can just do it if it's missing.
In terms of Clayton, I haven't done it because I haven't seen a big demand, but it's an open possibility, definitely.
Cool. So thank you. We hang around in the room or outside and have to stop right now. Thank you very much.
Thanks.